Today we are going to discuss about a chapter in fluid mechanics and machinery, second year, third semester course, subject code ME 630202. I am Dr. S.Mareeswaran. We are going to see about today the hydraulic machines. What is hydraulic machines? Hydraulic machine is a machine which convert either hydraulic energy into mechanical energy or mechanical energy into hydraulic energy. Those machines convert the hydraulic energy into mechanical energy. That machines are called as turbines, and those machines are converting mechanical energy into hydraulic energy called pumps. So we will see one by one. First of all, turbines. A turbine is a machine which converts hydraulic energy into mechanical energy, which is used in a hydroelectric power plant to utilize the hydraulic energy which is generated from a dam, and the dam water is made to flow through a pipe called a penstock pipe, and at the end of the penstock pipe there will be a nozzle, and that nozzle convert the all pressure energy into kinetic energy. Third, high kinetic energy of hydraulic is collide on the blades or vanes of a turbine, and thus the turbine is rotating. The rotation is transferred to a generator, car, or electrical generator to produce electricity. This is the simple sheet showing that hydroelectric power plant. See that dam is there. The water is filled in the dam, and there is a pipe, water flowing. That pipe is called penstock pipe, and then at the end of the penstock pipe, where the water is getting out and flowing through the turbine plates, and the flown water has come down through the draft tube, and because of the energy possessed by the water, that means hydraulic energy, is converted into mechanical energy. That means in the shaft we are having power. That power is coupled with that power is transferred to the generator, which is coupled to the turbine, and thus we are producing electricity. So now, classification of hydraulic turbines. Turbine is classified according to 4 categories. One is type of energy at inlet, the direction of flow of water through the runner, and head at the inlet of the turbine, and the specific speed of the turbine. According to types of energy, turbine is divided into types. One is impulse turbine, another one is reaction turbine. The example for impulse turbine is Pelton wheel, and example for reaction turbine is Francis and the Kepler turbines. According to direction of flow through the runner, the turbine is classified into 4 categories. It's a tangential flow turbine. Example is Pelton wheel. Radial flow turbine. Example is Francis turbine. Axis flow turbine. Example is Kepler turbine. And mixed flow turbine. Example is modern Francis turbine. In radial flow turbine, the flow of water will be in the radial direction to the wheel. Sorry, tangential flow turbine means in the tangential direction of the blade, and the radial flow means in the radial direction, and axial flow means through the axis of the shaft on which the blade is mounted, and mixed flow means these 3 flow can be mixed to get a hydraulic energy. And according to the head at inlet of the turbine, it's categorized into 3: high head turbine, medium head turbine, and low head turbine. So high head turbine will have maximum head as 350 meter, and medium head turbine will have a head of 60 meter to 250 meter, and low head turbine will have a head of less than 60 meter. And the example for 3 is Pelton wheel, Francis turbine, and Kepler turbine respectively. According to specific speed, high specific speed turbine, medium specific speed turbine, and low specific speed turbine. Example for a Pelton impulse turbine is Pelton wheel, one in which all energy of water is converted to kinetic energy before the water strike the vanes of the runner or strike the blades of the runner. This is done by passing through a flow nozzle or some gauge lines. The runner is rotated by force of water, and water passes over the wheel at atmospheric pressure. A reaction turbine means water entering into the wheel of the turbine has both kinetic energy and pressure energy, and that is total head of the water striking the runner wheel consists of partly pressure head and partly kinetic head. An example is Francis turbine, propeller turbine, and Kaplan turbine. So radial flow turbine is already we explained that in a turbine in which the water as it moves along the vanes flow towards the axis of the rotation or away from it, called a radial flow turbine. There are two types of radial flow turbine. One is inward flow turbine and upward flow turbine. In the inward flow turbine, water is flowing towards the axis of rotation, it's called inward, and water is flow away from the axis of rotation is called outward flow turbine. Axial flow turbine, it's a turbine which water enters the runner wheel parallel to the direction of axis of rotation of the runner. Example, Kaplan turbine and propeller turbine. In tangential flow turbine, it's a turbine in which the water strikes the runner wheel tangentially to the path rotation. Example is Pelton wheel. These are all the main components of the Pelton wheel. Main one is penstock pipe. At the end of the penstock pipe, there will be a nozzle and flow regulating arrangement. And the second one is runners and buckets. Runner is motor and shaft, and buckets are welded in the circumference of the runner. And third one is casing. The casing is one which is avoiding the water to flow out of the buckets after colliding. And number 4, braking. Jet is the one which is coming out from the nozzle. It's controlled the amount of water cycling in the veins of the runner, and casing it is used to prevent the splashing of water. A runner and bucket, it is a circular disc on the periphery on which evenly spaced buckets are fixed, and the function of the jet is to stop the runner in a short time period. Working of Pelton wheel, the flow of water is tangential to the runner, so it is a tangential flow impulse turbine. The runner consists of a single wheel mounted on a horizontal shaft. Water flows towards the turbine through a pipeline called a penstock and flows through a nozzle. The high-speed jet of water hits the buckets or vanes on the wheel and causes the wheel to rotate. A spear rod which has a spear-shaped end can be moved by hand wheel to control the flow of water coming out from the nozzle, and this movement controls the flow and water leaving the nozzle before it strikes the buckets. And the bucket or vanes is so shaped that when the water strikes, it gets split into two and gives it an impulse force in the center of the bucket. This bucket is also known as a splitter. These are all about the simple explanation for a turbine, and we have given an example for impulse turbine, and we explained the Pelton wheel. And now we are going to see about the pumps. So pump is a device which already we told it is converting the mechanical energy into hydraulic energy. The pumps are different types of pumps are there. Pumps are classified into rotodynamic pumps, positive displacement pumps. Rotodynamic pumps are classified into 3 categories. One is radial flow, another is axial flow, another is mixed flow. Similarly, positive displacement pumps are classified into reciprocating pumps and rotary pumps. These reciprocating pumps is further categorized into 2 types. One is piston or plunger type pump and diaphragm type, and rotary pumps are again categorized into 3. One is gear pump, another one is vane pump, another one is screw pump. Here we are going to see about the reciprocating pump, and which is a hydraulic machine which converts mechanical energy into hydraulic energy. It works by sucking liquid into a cylinder containing a reciprocating piston, which exerts a thrust on the liquid and increases its hydraulic energy, that is pressure energy of the liquid. It is also called as a positive displacement pump, which consists of piston or plunger. The piston is present in a cylinder in which it does reciprocating the motion, that is back and forth motion. It is used at a place where relatively small amount of water is to be delivered at a high pressure. So these are all the main parts of reciprocating pump. Mainly it's a cylinder which consists of piston rod, and piston rod is connected with the crank, and suction pipe, delivery pipe, suction valve, delivery valve, and air vessels. The operation is the suction valve is its function of suction valve is to open during the suction stroke, and water from the sump or a tank is sucked to the cylinder through the suction valve and closed during the compression of the liquid. Function of delivery valve is opens during the compression of the liquid and remains closed when the water is sucked from the water tank. See that diagram. See, it's clearly explained on this here and on this here. See all. See, cylinder is consisting of piston rod, and piston rod is connecting with the connecting rod. Connecting rod is crank, the crank, and the crank is rotating crankshaft. When the motor is on, the electrical motor is on, that electrical motor can generate the mechanical energy. That mechanical energy is coupled with the reciprocating pump, and when while the rotation of a crank, the piston moves right, left. While piston is moving to the left hand direction, suction valve is opening, and water is flowing through the suction valve and fill into the cylinder. At the same time, the delivery valve is in closed condition. And when the piston moves from right to left, the suction valve is closed, and delivery valve is partly open, while the piston is moved to the end of the left. Completely the suction valve is opening, and compressed water or pressurized water is delivered through the delivery pipe. So this is the types of reciprocating pump. One is a single acting reciprocating pump, and another one is a double acting reciprocating pump. In single acting reciprocating pump, only one side of the piston engages to display the liquid. Example, piston type syringe. And double acting reciprocating pump has both sides of piston engages to displace the liquid. In each stroke of the piston, two processes, suction and discharge, carried out at the same time. It consists of two inflow and two outflow pipes. This is the diagram of the single acting reciprocating pump. See, during the suction stroke, piston moves backward, and this opens the suction valve, while making the water enter into the cylinder. During the suction, the delivery valve remains closed and no water is discharged. As we discussed earlier, after the suction stroke, the piston moves towards forward, that means left hand side. Delivery valve gets opened and the suction valve come to closed position. As the piston moves forward, it exerts a thrust force on the liquid and it starts escaping out of the cylinder through the delivery pipe. This is the diagram of the double acting reciprocating pump. See, both sides we have a space to move. That means right hand side and also left hand side. As the piston moves to the right hand side, shown in figure 1, the following process takes place at the left and right side. The suction valve opens and delivery valve closed. The water from the reservoir sucked into the cylinder. At right side, the suction valve gets closed and delivery valve gets open. The water sucked in the previous stroke is discharged out of the cylinder. In each stroke of the piston, both suction and discharge of the liquid takes place at the same time. If suction is taking place at the right side and discharge takes place at the left side, vice versa. In reciprocating, the slip is main term. It is defined as the difference between the theoretical discharge and actual discharge of the reciprocating pump. The actual discharge of the reciprocating pump will be less than theoretical discharge of the pump due to leakage of water during the operation. Therefore, the slip of reciprocating pump is equal to Q theoretical minus Q actual. The advantages and the disadvantages of the reciprocating pump. Advantages are high pressure is obtained at the outlet. Priming process is not needed in this pump, and it provides high suction lift, and it is also used for air. And as far as the disadvantages is concerned, it requires high maintenance cost because of more wear and tear of the parts. And since it is reciprocating, so we may expect more wear and tear in the parts. And low flow rate and discharge low amount of water, and they are heavy and bulky in size and high initial cost is there. And applications, the application of reciprocating pump is an oil drilling operations, pneumatic pressure systems, and light oil pumping and feeding small boiler condensate to it. So these are all about the reciprocating pump. In the next video we will see about rotary pumps and its types called gear pump, vane pump, and screw pump. Okay, thank you.